Verify that each of the following is an identity. To do that, you have to make sure that the left side and the right side are the same thing. For this problem, I would change tangent of x to sine over cosine. It's using quotient identity. Notice the cosines cancel. Then you get sine of x divided by sine of x. Anything divided by itself is 1. 1 equals 1. Number 2, same directions. 1 plus tangent squared of theta is secant squared of theta. That's a Pythagorean identity. If you then change the left side to terms of sine and cosine using the reciprocal identities, and instead of dividing a fraction by a fraction, multiply it by the reciprocal of the bottom, you combine these fractions together, you get sine squared over cosine squared, which of course is the same as tangent squared. It's another quotient identity. We have two fractions here that need subtracted, so let's subtract them. To do so, you need common denominators. The left fraction needs multiplied by cosine on the top and bottom. Fraction on the right needs multiplied by sine on the top and bottom. If you subtract those two fractions, which means you subtract the tops, leave the bottoms the same, you get 1 minus sine squared of theta, which is the same thing as cosine squared of theta. You can cancel cosine from the top and the bottom, so you get cosine of, I said theta before, cosine of alpha over sine of alpha, which of course is cotangent. There's a little explanation for some of the more difficult parts here. 1 minus sine squared of theta, or alpha. Why is that cosine squared? Well, if you go to the first Pythagorean identity, sine squared plus cosine squared is 1. If you get cosine squared of alpha by itself, you get it equals 1 minus sine squared of alpha. That's how that becomes that. Another part here that you might not have followed, secant of alpha times cosine of alpha is 1. That's because secant is the same thing as 1 over cosine. When you multiply two reciprocals, you get 1. Number 4, this left side here I would change to fractions. Tangent sine over cosine. Sine as a fraction would be sine squared. And then if you want to get common denominators, you're going to have to multiply the top and bottom of sine squared by cosine squared. So it's the same denominator as the first fraction. Then you can subtract the numerators. There's no like terms up there. If you then factor sine squared out of the numerator, you get the following. Notice that 1 minus cosine squared of theta is sine squared of theta. Looking at the right side of the equation, I need to get a tangent squared in there. I notice on the left side I got sine over cosine, which is tangent. And that makes the right and left side the same. Once again, why is 1 minus cosine squared of theta sine squared of theta? It's because of this Pythagorean identity. When you get sine squared by itself, you get 1 minus cosine squared of theta. Number 5, I would take the right side and I would change the tangent to sine over cosine, and I would change the secant to 1 over cosine. Then in my numerator, I'm adding 1 plus a fraction. Change the 1 to have a common denominator. Add the fractions. When you add the numerators, leave the bottoms the same. Now I have a complex fraction. Both the numerator and denominator are simplified. Take the denominator, reciprocate it, and multiply it by the numerator. So I flipped over 1 over cosine to cosine over 1. Notice the cosines cancel. You're left with cosine of theta plus sine of theta. Using the commutative property, we can make it to sine of theta plus cosine of theta, which is the same thing that the left side is. Number 6, I see two fractions. Anytime I see two fractions, I like to add or subtract them together. So to do so, I need to get common denominators with cotangent to the 4th. So I'm going to multiply the right fraction top and bottom by cotangent squared. Combine the fractions. Notice in my numerator, using the Pythagorean identity, 1 plus cotangent squared of alpha is cosecant squared of alpha. Now I'm going to change both the top and bottom to sines of cosine and into terms of sine and cosine. I have a complex fraction, so I multiply the reciprocal at the bottom. And cancel sine squared from the top and the bottom. Gives me sine squared of alpha over cosine to the fourth of alpha. And at this point, I have no idea what to do next. I'm going to go look at the left side of the equation, see if I can do anything with it. Since the right side, I really don't know what to do. The left side here, I can factor out a secant squared. And then using the Pythagorean identity, secant squared of alpha, which is right here, I can replace with tangent squared of alpha plus 1. These parentheses there are just to point out that I'm substituting. It has no mathematical value here. Then the 1's are going to cancel. We got a plus 1 and a minus 1, which then gives me an idea over here on the right, because that right side is pretty close to this. If I rewrite this right side as 1 over cosine squared of alpha times sine squared over cosine squared. 1 over cosine squared is secant, sine over cosine is tangent. Left and right side are now the same. Number 7, once again I'm subtracting two fractions. What do? You get common denominators. It's that simple. And that is not what I did. What I chose to do instead, you could get common denominators and it would work. Apparently I didn't do that. I changed the divided by cosine to times 1 over cosine. So instead of dividing, you multiply the reciprocal. I changed dividing by cotangent to times 1 over cotangent. Then 1 over cosine is secant, 1 over cotangent is tangent. Secant times secant, secant squared. Tangent times tangent is tangent squared. Using Pythagorean identity, secant squared of beta, or b in this case, is tangent squared of b plus 1. Just bring the subtract tangent squared of b down. Your tangent squared of b's cancel, so you get 1 is 1. This next one, the left side is the most complicated, and I've encouraged you to use the most complicated side first. But it is so complicated, I don't know where to start. So I'm going to start on the right side. I'm going to change tangent and cotangent to terms of sine and cosine using the quotient identities. Then I'm going to get common denominators. So the left fraction needs multiplied by sine on the top and bottom. The right fraction needs multiplied by cosine on the top and bottom. Subtract your fractions. What's nice about what we have right now is the bottom of our fractions are the same on the left side of the equation and the right side. If you look at the tops, the numerators, this one has cosine squared in it. This one has a cosine squared in it. That's great. This has a sine squared. This left side doesn't. Somehow I need to get rid of a sine squared. So how can I do that? If I use Pythagorean identity, I can change sine squared of x to 1 minus cosine squared of x. If you combine like terms, you're subtracting cosine squared of x twice. That means 1 minus 2 cosine squared of x. Left and right sides are the same. Once again, how does that equal that? Pythagorean identity, getting sine squared by itself. That's how they equal each other. Find a numerical value of one trig function of each x. So on the left or the right, either one, we need one trig function by itself. On the other side, we need a single number. If you change tangent to sine over cosine, and then take this complex fraction and make it simple by, instead of dividing by sine, make it times 1 over sine, your sines cancel. So it's 1 over cosine of x equals square root of 2, which is secant of x equals square root of 2. This is one answer. There are 5 other answers that also work. Refer to the answer key if you got an answer different than this and you want to see if it's right. Same directions for number 10. I'm going to change secant and cotangent to terms of sine and cosine. Gives me sine of x over cosine of x. Instead of dividing by cosine over sine, I'm going to multiply its reciprocal, sine over cosine. Gives me sine squared over cosine squared. which is tangent squared, square root both sides, you get tangent is plus or minus 3/4. When you square root a fraction, you square root the top and the bottom. Number 11, change everything to terms of sine and cosine. Cosines cancel. Instead of dividing by a fraction and multiply by the reciprocal, you get sine squared is 1/9. Therefore, sine of x is 1/3. Plus or minus, of course. Once again, this is one answer of 12 because it's plus or minus. So if you get a different answer than this, check the answer key and see if you got it right.